Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, Safety and Concurrency. Our initial trading engine, prototyped in Python, served well for initial validation. However, as we scaled, latency became a critical constraint. We observed unacceptable slippage on larger trades and inconsistent order execution times, directly impacting our Sharpe ratio and overall profitability. The global interpreter lock, GIL, in Python severely hampered our ability to fully utilize multi-core processors for concurrent order processing and market data analysis. We evaluated several languages including Go and C++. While Go offered concurrency, its garbage collection introduced unpredictable latency spikes. C++ provided performance but lacked the memory safety guarantees we needed for a system managing significant capital. Rust's ownership model and borrow checker offered the ideal balance. Near C++ performance with significantly reduced risk of memory leaks and data races. Benchmarking confirmed substantial latency improvements. Post-migration to Rust, our average order execution latency decreased by over 70%. Critically, the variance in latency was also significantly reduced, leading to more predictable and consistent performance. This reduction directly translated to decreased slippage, improved fill rates, and a more robust trading strategy resilient to market volatility. Real-time context from 2024 suggests similar latency drops are achievable when migrating from Go to Rust for trading systems. The move to Rust wasn't solely about speed. The inherent memory safety features of Rust mitigated the risk of critical errors like buffer overflows or use after free vulnerabilities. These errors, which can be extremely difficult to debug and can lead to catastrophic losses in a live trading environment, are largely prevented by Rust's compile time checks. This translates to lower operational risk and increased confidence in our system's reliability. Rust's lightweight concurrency primitives, such as threads and async, await, enabled us to fully leverage multi-core processors for parallel order execution, risk management calculations, and market data processing. We implemented a custom agentic loop in Rust that efficiently manages concurrent tasks, ensuring optimal resource utilization and minimizing contention. This architecture allows us to handle a significantly higher volume of trades without compromising performance. Our current architecture utilizes Rust for the core trading engine, coupled with customized agentic loops for dynamic strategy adjustments. These loops leverage a private RAG, retrieval augmented generation system, also built in Rust, to access and analyze vast amounts of historical market data and research reports. This allows our AI-powered models to make more informed trading decisions in real time, further optimizing profitability and risk management. For future scalability, consider distributed Rust architectures leveraging technologies like Apache Kafka for message passing and Kubernetes for container orchestration. Continuously monitor resource utilization and optimize code for SIMD instructions and other hardware-specific optimizations. Also, investigate hardware acceleration using FPGAs or GPUs for computationally intensive tasks such as options pricing and risk simulations. Regular security audits are paramount to ensure the integrity of the system. Start with small, modular components and gradually migrate functionality from your existing system to Rust. Focus on areas where performance is most critical. such as order execution and market data processing. Invest in comprehensive testing and benchmarking to validate performance improvements and ensure system stability. Consider using existing Rust crates like Tokyo for asynchronous programming and ND array for numerical computation. Do not rewrite everything at once. Incremental migration minimizes disruption. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.